Okay, pre-cal 11, here we go, section 1.1. So this, you could say this is our first, my name isn't pre-cal. You could say this is my first official section. The last one was review, but still, it's good to practice and learn everything. We're going to start with radicals. Now, we've talked about radicals many times, and that's just the symbol for square root, right? This symbol here. But the thing is we deal with way more than just square roots now. Cube roots, fifth roots, seventh roots, it doesn't matter. And whatever the root is the n. So just think, if you have 2 to the power of 16, the 16th root of that is just 2. It unzips the zipping that is exponents, right? Like 5 squared is 25, zips, square root of 25 is 5. Essentially the radical symbol to the same index, which is what this n means, gets you back to what the original base was to start with. So another thing that's important is, for the longest time when you were doing Pythagorean theorem and stuff, you'd say, oh, well, the square root of 25 is 5. And when you're talking measurement, yeah, you're right, because there's no negative measurement values. But when we're dealing strictly mathematically, square roots have 2 answers, positive and negative, because it's the same number multiplied by itself twice. And both 3 times 3 and negative 3 times negative 3 equal 9. So the square root of 9 is plus or minus 3. The square root of 6 is positive root 6, negative root 6. Now, there's one to consider. If it's not a perfect square root, so 9 is a perfect square, so it has a square root of 3, but 6 is not a perfect square, but the square root is still the square root of 6. The square root of 6 is a number. Treat it that way. Be nice to it. Okay, don't disregard. That is a number called root 6. Okay? If you have an even index, okay, then you have positive and negative answers. And that goes back to the first thing we talked about in section 1.0, is if you have an even number of negatives multiplying by themselves, if you have a negative number multiplied by itself an even number of times, the answer is always positive. So if you have an even exponent, you will always have plus or negative as your answers. If you have an even exponent, but the answer is negative, that does not exist. That's not possible. It's not possible to multiply a number by itself twice and end up with a negative solution. Now, it's not possible in what's called the real number system. If your math journey extends further, we get to what's called the complex number or imaginary number system, and then boom, you can take the square root of a negative number, but I don't want you to worry about that right now. In the realm we live in, no solution to those things. You cannot have a negative number answer if you have an even exponent. If you have an odd exponent, world's your oyster. You most definitely can. You have the cube root of 8. You only have one answer though, right? 2. Not plus or minus 2, because negative 2 times negative 2 times negative 2 is a negative answer, which is why you do have a cube root of negative 8, and it's negative 2. And you do have a fifth root of 4. It's the fifth root of 4. Okay? And this is just what I meant by the zippering, right? If you take the fifth root of 4 and you put it to the power of 5, that cancels with that. And you're just left with the base. The roots unzip the powering. And then if you have any power that is equal to 0, well, the answer is just 0. So just a reminder of the properties that we looked at. Now this is for any positive n, okay, which means that number is positive. So 1 over n is the nth root of a, so 2 to the power of 1 over 4 is the fourth root of 2. And this we did this last section. This is just more abstract. This is the flower power. This is when you have a negative exponent. You have to put in the denominator first, and then you flower power. And this is if you have the root of a fraction. So if you have the third root of 2 over 3, and you'll notice A and B are not the same, okay? Then you have the third root of 2 over the third root of 3. This is an important dynamic you're going to see in the next few pages. In the next section. So here we get just practice. Now, solve for x. Well, you have x squared, so you need to take the square root of 4. Sorry, my pen stopped working. You have the square root of 4. And if you're taking the square root of 4, you are going to get plus or minus 2, right? 2 answers. But what about here? You have something squared equals a negative. Is that possible? No. Boom. Okay, no answer. That should jump on your head. No, that's not a 0. That's called the empty set. No possible solution. So work your way through this stuff. Get some practice. You're going to simplify this using exponents. So I'll do one of these for you. You have 9x squared rooted, so it means you have this, right? Which means you have 9 to the half x squared, right? Multiply water bomb, so you got to multiply the exponents, which means 1/2 of 9 is the square root of 9, so 3. And then 2 times a half, those 2's cancel. Just left with x. Okay, let's do one more for you. You have x to the 5 to the 1/2, which means you have x to the 5 halves. Now, here's what, that's not simplified, because x to the 5 halves is x to the 2 over 2 times x to the 2 over 2 times x to the 1 over 2. And why do I do that? Well, that's because boom, boom, you have x times x times x to the half, which means you have x squared times the square root of x. Those ones are going to be a little bit trickier, but practice, practice, practice. Okay, good job.